Data structures, or structured variables, are variables that store more than one value. Arrays that we've been using so far, for example, number vectors or number matrices, are one type of data structure in which all of the elements are the same type, and in some sense they represent the same thing. For example, if you had a vector of all item costs, then they would all be numbers and they would all represent costs of items. A cell array is a different type of data structure that can store different types of values in its elements. A cell array could be a vector, either a row vector or a column vector, or it could be a matrix. It is an array, so what that means is that indices are used to refer to the elements in the vector or the matrix. One of the best applications of a cell array is to store strings that have different lengths. Since the elements can store different type of values, the elements can store strings of different lengths. The syntax used to create a cell array is to use curly braces instead of the square brackets that we've been using for other arrays. The direct method of creating a cell array is to put values in the rows, separated either by commas or spaces, and then to separate the rows with semicolons. So in other words, exactly the same syntax that we've already been using for other types of arrays. The difference is that we're putting them inside of curly braces instead of inside of the square brackets. If you want to pre-allocate a cell array, you can do that using the cell function. So you pass to the cell function of the dimensions of the cell array. For example, cell 4, 2 would pre-allocate a 4 by 2 cell array. You need to be able to refer to the different elements in a cell array. So first of all, the elements in a cell array are called cells. There are two different methods of referring to the parts of cell arrays. You can refer to the cells, that's called cell indexing, and you use parentheses to do that. Or you can refer to the contents of the cells. This is called content indexing, and we use curly braces for that. For example, I create a cell array. The variable is called CA. It stores in it two things. First of all, the vector 2, 3, 4, and secondly, a string. So again, different types of values in the two elements in my cell array. If I refer to the first element in the cell array using cell indexing by saying CI parentheses 1, it just shows me that it's a 1 by 3 double, but doesn't show me the actual contents. If I use content indexing, however, by saying CA curly braces 1, then it will show me the actual contents of the first element of the cell array. So notice that we use curly braces to create the cell array to begin with, and then also we use curly braces for the content indexing for the elements of the array. There are several functions that you can use with cell arrays. First of all, to display, there's the cell disp function. That will display the contents of all of the elements of a cell array. And the cell plot function puts a graphical display in the figure window, but it just shows the cells. It doesn't show their contents. Since the best use of a cell array is to store strings of different lengths, if you have a character matrix that stores strings, you can convert that to a cell array of strings using the cell string function, or cell str. Doing the reverse, you can use char to convert from a cell array that stores strings to a character matrix. The isCellString function, you pass to that a variable, and it will return logical 1 for true if the cell array that you pass to it is in fact a cell array of all strings, or false if it's not all strings. So again, one of the best uses of a cell array is to store strings of different lengths.